A dead killer doesn't kill again. So while I'm disappointed the firing squad won't get to take their shots at you,
Hereby sentence Mr. Kohberger as follows.
There's a photograph. You can't see it yet, but it exists. Somewhere in a climate-controlled evidence room in Moscow, Idaho, there's a leather knife sheath inside a plastic evidence bag. On that sheath, invisible to every human eye that has ever looked at it, are 7 microscopic skin cells. 7 cells. Each one is roughly 30 micrometers across. To give perspective, a human hair is about 70 micrometers wide. These cells are half that size. You could fit 200 of them on the head of a pin. And those 7 cells, smaller than a grain of pollen, lighter than a whisper, are about to end a man's life. Case 1. Bryan Kohberger. He's 28 years old. He has a master's degree in criminal justice. He's currently pursuing a PhD in criminology at Washington State University, where he studies one very specific subject: how killers get caught. On November 13, 2022, at approximately 4 in the morning, 4 university students were stabbed to death in their beds in a rental house near the University of Idaho campus. The attack was surgical, clinical, the kind of violence that doesn't scream, it whispers. By the time the sun rose over the Palouse Hills that morning, the killer was already gone. No witnesses, no weapon, no clear motive. Just 7 cells on a piece of leather. And here's what makes those 7 cells so terrifying. Bryan Kohberger knew they were there. He had to. This is a man who spent years studying forensic science, a man who wrote academic papers on how law enforcement uses genetic databases, a man who understood better than most detectives exactly how the genetic dragnet works. He knew. And he left them anyway. Because here's the thing about DNA that no one tells you. It doesn't care what you know. It doesn't care how smart you are, how carefully you've planned, how many textbooks you've read about forensic countermeasures. DNA is the one witness that never blinks, never forgets, and never, ever lies. Over the next hour, you're going to meet 10 people who learned this lesson the hardest way possible. A Manhattan architect caught by a single hair on burlap. A grandfather arrested 40 years after he thought he'd buried his past. A delivery driver trapped by the GPS signal in his own truck. A serial predator exposed when his own son got arrested. 10 different people. 10 different decades, 10 different methods, but every single one of them made the same fatal mistake. They forgot that their body is a witness they can never silence. So let's start with the question that's going to haunt this entire story. If Bryan Kohberger was smart enough to study how killers get caught, why wasn't he smart enough to avoid getting caught himself? The answer is going to take us deep into the science of something called touch DNA, through a trash pull operation at his parents' house in Pennsylvania, and into a courtroom where the prosecution is building a case with evidence you literally cannot see. But before we get there, you need to understand something about the genetic revolution that's currently rewriting every cold case in America. Let me take you back to 1984.
That's the year Alec Jeffreys, a geneticist at the University of Leicester, accidentally discovered that human DNA contains repeating patterns, sequences of genetic code that repeat over and over like a stutter in the language of life. He called them mini-satellites. What Jeffreys realized in a moment that would change criminal justice forever was that the number of times these sequences repeat is different for every human being on Earth. Your DNA has a specific number of repeats at specific locations. My DNA has different numbers at those same locations. It's like a biological barcode, written in molecules instead of ink. Jeffreys called it DNA fingerprinting. Law enforcement called it a miracle. By 1987, DNA evidence was being used to solve its first murder case. A man named Colin Pitchfork became the first person in history to be convicted of murder based on DNA profiling. The technique was crude by modern standards. It required a blood sample the size of a quarter, but it worked. Fast forward to 2024, and the technology has become so sensitive it borders on science fiction. That knife sheath in Moscow, Idaho, the one with Bryan Kohberger's 7 microscopic skin cells, modern forensic labs can extract a full DNA profile from that. They can take cells so small you'd need an electron microscope to see them. Cells that have been sitting in a room for weeks. Cells that have been contaminated by dust and air and the oils from evidence gloves. And they can still pull out enough genetic information to identify one specific human being out of 8 billion people on this planet. It's called touch DNA, and it's everywhere. Right now, as you're watching this, you're shedding approximately 30 to 40,000 skin cells per minute. Most of them are dead. Your body is constantly replacing the outer layer of your epidermis, sloughing off old cells like a snake shedding its skin. Those cells fall on your clothes, your furniture, your phone screen, your car's steering wheel. Every surface you touch becomes a genetic crime scene. Every door handle is a confession. Every coffee cup is a signed statement. This is the world Bryan Kohberger was living in when he drove to Moscow, Idaho in the early morning hours of November 13th, 2022. Think about what that means for just a second. You are constantly, involuntarily, leaving biological evidence of your existence everywhere you go. You cannot stop it, you cannot control it. Even if you wear gloves, and Kohberger allegedly did, you're still shedding cells inside those gloves. And the moment you touch something with those gloves, the moment you adjust them or remove them or brush against a surface, those cells transfer. This is what forensic scientists call Locard's exchange principle. Every contact leaves a trace. Edmond Locard, the French criminologist who came up with this principle in the early 1900s, was talking about things like fibers and soil and fingerprints. He had no idea that one day we'd be able to use molecules invisible to the naked eye as evidence. But here's what makes the Kohberger case so psychologically fascinating. He knew this. He had to know this. This wasn't some street criminal who'd never heard of forensic science. This was a graduate student who had literally studied the history of DNA evidence, who had read the case files, who had written papers on it. So why did he leave that sheath behind? We're going to come back to that question, but first, you need to understand exactly how the police went from 7 invisible cells on a piece of leather to a SWAT team surrounding a house in Pennsylvania at 4 in the morning, 7 weeks after the murders. The answer involves something called STR analysis, short tandem repeat analysis, and one of the most controversial investigative techniques in modern law enforcement, the trash pull. Here's how STR analysis works, and I need you to stay with me on this because it's going to matter for every single case we cover tonight. Inside every cell in your body, there's a nucleus. Inside that nucleus are 23 pairs of chromosomes. Those chromosomes are made of DNA, deoxyribonucleic acid, which is essentially a 4-letter code repeated 3 billion times. The 4 letters are A, T, G, and C: adenine, thymine, guanine, and cytosine. Now, most of your DNA is the same as everyone else's. About 99.9% of your genetic code is identical to mine, and to your neighbors, and to a stranger on the other side of the world. We're all human. We all have the basic blueprint. But that remaining 0.1%, that's where you live. And hidden inside that 0.1% are these repeating sequences, STRs, that are unique to you. Forensic scientists have identified 13 core locations on the human genome where these repeats happen. They call them loci. At each locus, you have a certain number of repeats. Maybe you have 8 repeats at one location and 12 at another. I might have 7 and 15. When a forensic lab analyzes a DNA sample, they're counting the repeats at these 13 locations. The result is a genetic profile, a string of numbers that is statistically unique to you. The odds of 2 unrelated people having the 13 loci STR profile? 1 in a trillion.
There aren't even a trillion people on Earth. This is what the Idaho State Police Crime Lab did with those 7 cells on the knife sheath. They extracted the DNA. They amplified it using a technique called polymerase chain reaction, PCR, which essentially photocopies the genetic material millions of times until there's enough to analyze. Then they ran it through an STR analyzer. What came out was a male genetic profile. Unknown male. No match in CODIS, the Combined DNA Index System, the FBI's national DNA database containing profiles from about 20 million people, most of them convicted felons and RSDs. Which meant one of 2 things. Either the killer had never been arrested before, or he'd managed to avoid giving a DNA sample during previous arrests. This is where most cold cases die. You have DNA from the crime scene, you have a profile, but if that profile isn't in the database, you have nothing. It's like having a photograph of the killer's face, but the photograph is of someone who's never had their picture taken before. Dead end. Except, the Idaho investigators didn't stop there. They did something else, something newer. Something that's only become widely available in the last decade, and something that's currently sparking massive legal and ethical debates across the country. They use that DNA profile to search a different kind of database. Not a law enforcement database, not a government database, a genealogy database. And that's when they found Bryan Kohberger's family. But before we get into how that genealogy search worked, I need to tell you about the 4 people who died that night. Because here's what happens in a lot of true crime coverage. The victims become abstractions, statistics, plot points in someone else's story. And that's not just wrong, it's a failure of empathy. Kaylee Gonzalez was 21 years old. She'd just gotten a job offer in Austin, Texas. She was supposed to move there with her best friend, Madison Mogan, who was also 21. They'd been inseparable since 6th grade. They were planning their entire future together. Zana Kernodle was 20 years old. She was studying marketing. She had a boyfriend, Ethan Chapin, who was 20. He wasn't even supposed to be at the house that night. He lived in a fraternity house across campus, but he'd stayed over because he wanted to spend time with Zana. 4 people, 4 futures, 4 entire universes of possibility collapsed in the span of minutes. The knife that was used, and we know this from the autopsy reports and the surviving roommate's statements, was a large fixed-blade knife, probably a K-bar or something similar, military style, the kind of weapon designed for a single purpose. The coroner later said that some of the victims had defensive wounds, which means they woke up, which means they fought, which means in their final moments they were aware of what was happening to them. And the person doing it walked out of that house, got in his car, and drove away. For 7 weeks he went about his life. He attended his graduate classes. He graded papers. He interacted with students who had no idea what he'd allegedly done. And the entire time, those 7 cells were sitting in an evidence room, waiting to speak. Here's how familial DNA searching works and why it's both brilliant and deeply controversial.
When you submit your DNA to a genealogy website like GEDmatch or Family Tree DNA, you're uploading your genetic profile to a database that's designed to find your relatives. The algorithm compares your DNA to everyone else's DNA in the system, looking for shared segments, pieces of genetic code that are identical because they were inherited from a common ancestor. If you share a lot of DNA with someone, you're closely related. Parents and children share about 50% of their DNA. Siblings share about 50%. First cousins share about 12.5%. The more distant the relationship, the less DNA you share. But even distant relatives, third cousins, fourth cousins, share small segments that can be detected. Now here's what law enforcement realized about a decade ago. If you have DNA from a crime scene and you can't find the perpetrator in CODIS, you can upload that DNA profile to a public genealogy database and search for the perpetrator's relatives. You're not looking for an exact match, you're looking for partial matches, people who share enough DNA with the unknown perpetrator that they're probably related to him. Once you find those relatives, you build a family tree. You use public records, birth certificates, marriage licenses, obituaries, census data to map out the entire expended family. Then you use traditional detective work to narrow down the pool of suspects. You look for the right age, the right gender, living in the right geographic area. It's like genealogy in reverse. Instead of using DNA to find your ancestors, you're using ancestors to find DNA. This is how they caught the Golden State Killer in 2018. Joseph James DeAngelo had terrorized California for over a decade in the 1970s and 80s. At least 13 murders, 50 rapes, over 100 burglaries. Then he vanished. For 40 years, he was a ghost. Until a forensic genealogist named Barbara Ray Venter uploaded his crime scene DNA to GEDmatch and found his third and fourth cousins. She built a family tree with over 1,000 people in it, narrowed it down to one man. The police followed him, took DNA from a discarded tissue in his trash can, and matched it to the crime scenes. He's currently serving life in prison without parole. That case opened the floodgates. Suddenly, law enforcement agencies across the country started using forensic genealogy to solve cold cases. The technique has been used to solve hundreds of cases now. Murders from the 1970s, rapes from the 1980s, Jane and John Does who died without names. It's the most significant advancement in forensic science since DNA fingerprinting itself. And it's also, depending on who you ask, either a triumph of justice or a massive violation of genetic privacy. Because here's the thing, if you've submitted your DNA to a genealogy website, you've potentially made every single one of your relatives searchable by law enforcement. Your third cousins, your fourth cousins, people you've never met and never will meet. And those people, those distant relatives, can lead to you.
Even if you've never committed a crime, even if you've never given your DNA to anyone, even if you've never been fingerprinted or arrested or even gotten a speeding ticket, your genetic privacy is only as strong as your most genealogy-obsessed relative. We'll come back to this, but first, let's talk about what happened in Pennsylvania. On December 23, 2022, 6 weeks after the murders, the Pennsylvania State Police set up surveillance outside a house in Albrightsville, Pennsylvania. Inside that house, Bryan Kohberger, home for Christmas break. The investigators had used forensic genealogy to build a family tree from the DNA on the knife sheath. They'd narrowed their suspect pool to a handful of individuals. Bryan Kohberger was at the top of the list. He was the right age, the right gender. He drove a white Hyundai Elantra, the same make and model that had been spotted near the crime scene multiple times in the weeks before the murders. He lived in Pullman, Washington, just 15 minutes from Moscow, Idaho. But they didn't have his DNA. Not yet. So they waited. They watched the house.
They documented everyone who came and went, and they waited for Bryan Kohberger to throw something away. On December 27th, in the early morning hours, investigators watched as trash was placed at the curb outside the Kohberger residence. The moment the family went back inside, the surveillance team moved in. They took the trash. This is legal, by the way. Once you put your trash on the curb for collection, it's considered abandoned property. You have no reasonable expectation of privacy for things you've thrown away. This has been settled law since the Supreme Court case California v. Greenwood in 1988. Inside that trash, the Pennsylvania State Crime Lab found something they were looking for: DNA from Bryan Kohberger's father. They ran it against the crime scene profile. Familial match. The DNA on the knife sheath was consistent with belonging to a biological son of the man whose DNA was in the trash. 3 days later, on December 30th, 2022, at approximately 3 a.m., a SWAT team surrounded the Kohberger residence. Bryan was taken into custody without incident. He was extradited to Idaho. He's currently awaiting trial, facing 4 counts of first-degree murder. So here's the answer to our earlier question. Why did Bryan Kohberger, a criminology PhD student who studied forensic science, leave a knife sheath with his DNA at a crime scene? The brutal truth might be this: he didn't think 7 microscopic cells would be enough. He probably knew that touch DNA is fragile, easily contaminated, difficult to process. He might have thought that even if investigators found the sheath, even if they extracted a profile, they wouldn't be able to use it in court. What he didn't count on was the genealogy trap. He didn't count on the fact that his DNA wasn't just his anymore. It was his family's. It was his ancestors'. It was a genetic map that led straight back to him, whether he consented to it or not. And here's what that means for every unsolved case sitting in an evidence room right now. The statute of limitations on DNA never expires. If you've ever felt like the worst people get away with the worst things because they're smarter than the system, because they've learned to hide, because justice moves too slowly, you're about to see why that's no longer true. Because what you just learned about Bryan Kohberger, that's not an isolated case. That's the beginning of a pattern. Let's keep going.
Case 2, Rex Heuermann. There's a house in Massapequa, New York. From the outside, it looks like it's dying. The paint is peeling, the yard is overgrown. There's a pickup truck in the driveway that hasn't moved in years, slowly rusting into the asphalt. If you drove past this house, you'd probably assume it was abandoned, foreclosed, forgotten. But someone lives there. His name is Rex Heuermann. He's 59 years old. He's 6'4", weighs nearly 300 pounds. He has a scraggly beard and glasses, and the kind of face that disappears in a crowd despite his size. Unremarkable, forgettable, ordinary. By day, he works as an architect in Manhattan. He's the principal of his own firm. He designs buildings in New York City, actual skyscrapers, structures that define the Manhattan skyline. He's a member of professional organizations. He files taxes. He pays his bills. He's lived in the same house for decades, married to the same woman, raising a stepdaughter. He is, by every external measure, normal, except for one small detail. Rex Heuermann is currently charged with murdering at least 6 women, possibly more. And the way they caught him involves one of the most patient, methodical, and frankly chilling surveillance operations in modern law enforcement history. Because Rex Heuermann knew he was being hunted. He just didn't know his body was the one doing the hunting for him. Let me take you back to December 2010. A police officer named John Malia is searching a stretch of Ocean Parkway on Long Island's South Shore. He's looking for a missing woman named Shannon Gilbert, who disappeared after making a frantic 911 call in May of that year. She told the dispatcher someone was trying to kill her.
Malia is with his cadaver dog, a German shepherd named Blue. They're walking along the brambled brush that separates the parkway from Gilgo Beach. It's desolate out here. Wind off the Atlantic, salt marsh grass, the kind of place where you could scream and no one would hear you. Blue alerts. They find human remains wrapped in burlap, partially buried. And then they find another, and another, and another. By the time the search is over, investigators have found the remains of 10 individuals along that stretch of beach. 4 of them were wrapped in burlap sacks. They'd been there for years, some of them since 2007 or earlier. The elements had reduced them to bones and fragments. But DNA doesn't care about time. Investigators extracted DNA from the remains. They identified the victims: Melissa Barthélemy, Megan Waterman, Amber Costello, Maureen Brainard Barnes. All 4 women had been working as escorts, advertising their services online. All 4 had disappeared between 2007 and 2010, and all 4 had been murdered by the same person. The police knew this because of something found with the bodies: burlap sacks. Specifically, burlap sacks that were identical in weave and manufacture. And on one of those sacks, caught in the rough fibers like a spider's web, was a single human hair. A hair with a root, which meant it contained mitochondrial DNA. Here's what you need to understand about mitochondrial DNA and why it matters so much for cold cases. When forensic scientists talk about DNA, they're usually talking about nuclear DNA, the genetic material inside your cells. That's the stuff we've been discussing with STR analysis. That's the 13 locus profile that's unique to you. But there's another type of DNA in your cells: mitochondrial DNA, or mtDNA. It lives in the mitochondria, the tiny organelles that power your cells, and it's passed down exclusively from your mother. Your mother gave you her mitochondrial DNA. Her mother gave it to her. Her mother's mother gave it to her. It goes back generation after generation in an unbroken maternal line stretching back thousands of years. Here's why that matters for forensics. Mitochondrial DNA is much more durable than nuclear DNA. Nuclear DNA degrades quickly when cells die, but mtDNA, it can survive for years, decades, even centuries under the right conditions. That hair on the burlap sack had been sitting in salt air and sand for potentially a decade. The nuclear DNA was too degraded to use, but the mitochondrial DNA was intact. The lab extracted it, they sequenced it, they created a mitochondrial profile, and then they waited. Because here's the problem with mitochondrial DNA: it's not unique. Remember, you inherited it from your mother, and your mother inherited it from her mother, which means you share the exact same mitochondrial DNA with your mother, your siblings, your maternal grandmother, your maternal aunts and uncles, your maternal cousins. It's not enough for a conviction. At best, it can exclude suspects. If your mtDNA doesn't match the crime scene mtDNA, you're ruled out. But if it does match, all that proves is that you're maternally related to whoever left that hair. So the hair from the burlap sack was cataloged, filed, stored, and for 13 years it sat in an evidence room, waiting for technology to catch up to the evidence. Jump to 2023. A task force has been quietly working the Gilgo Beach case for years. They've been using the same forensic genealogy techniques that caught the Golden State Killer. They've been building family trees, cross-referencing cell phone records, analyzing the victim's last known contacts, and they keep coming back to one name: Rex Heuermann. He fits the profile. He's the right age. He was living on Long Island during the time of the murders. His cell phone pinged off towers near the victim's last known locations. He owned a pickup truck. Witnesses had reported seeing a pickup truck near one of the victim's last sightings. But they can't arrest him, not yet, because they don't have his DNA. They need to connect him to that hair on the burlap sack. So the Suffolk County Police Department does something extraordinary. They put Rex Heuermann under 24-hour surveillance. Not the kind of surveillance where they occasionally drive past his house. I mean full, constant, dedicated surveillance. Multiple teams, rotating shifts, watching him every moment he's in public. They're waiting for him to discard something with his DNA on it. For months, they watch. They follow him to work in Manhattan. They watch him buy coffee. They watch him eat lunch. And every time he throws something away, a napkin, a cup, a plastic fork, they retrieve it.
But here's the problem. Rex Heuermann doesn't throw things away in public trash cans. He either takes his trash home with him or disposes of it in ways that make retrieval difficult or legally questionable. He might not know he's being watched, but he's careful, compulsively careful. Then, in January 2023, Rex Heuermann does something he's done probably thousands of times before. He orders pizza. He's in Manhattan, sitting in his office. He orders from a local pizza place. The delivery arrives, he eats, and when he's done, he throws the box away in a public trash receptacle outside his building. The surveillance team waits until he leaves. They retrieve the pizza box. Inside, a crust, half-eaten, teeth marks, saliva, nuclear DNA. The lab extracts it. They create a full STR profile, and then they compare it to the maternal DNA from the hair on the burlap sack. Familial match. The nuclear DNA from the pizza crust is consistent with being maternally related to whoever left that hair. But that's not all. The task force has also been using forensic genealogy to build Rex Heuermann's family tree. They've traced his maternal line back generations. They've identified every living maternal relative they can find. And they've been quietly collecting DNA from those relatives, from public records, from discarded items, from genealogy databases. Every single maternal relative matches the hair, which means the hair came from someone in Rex Heuermann's maternal line. Combined with all the other circumstantial evidence, the cell phone records, the vehicle, the geographical proximity, they have enough for an arrest warrant. On July 13, 2023, Rex Heuermann is arrested outside his office in Manhattan. He's charged with 3 counts of murder initially, then 3 more are added later. He's currently awaiting trial. And the entire case hinges on a single hair that was collected in 2010 and a pizza crust from 2023. Think about what that means. A single hair, thinner than a thread, left on a piece of burlap over a decade ago. It survived rain, wind, salt air, sand, heat, cold. It sat in an evidence room for 13 years waiting. And then, when the technology finally existed to use it properly, when the surveillance team finally got their break, when the pizza delivery finally arrived, that hair reached across time and grabbed the man who left it there. Your body is not loyal to you. It will testify against you even when you've tried your hardest to silence it. But here's the question that should be keeping you up at night. If mitochondrial DNA can survive for 13 years in hostile conditions, how far back can we go? How cold can a case be before it's truly unsolvable? The answer is going to take us back 40 years. Case 3. Raymond DJ Free. Imagine this. You're 70 years old. You've lived a quiet life in a small town. You've been married for decades. You have children, grandchildren. You coach Little League. You volunteer at your church. Your neighbors know you as a kind man, a helpful man, a man who mows his lawn on Saturdays and waves to people walking their dogs. You've been this person for so long that you've almost forgotten you were ever anyone else. Almost. Because every now and then, late at night when you can't sleep, a memory surfaces, something from 1978, something you buried so deep you convinced yourself it never happened.
But DNA doesn't forget. And on a cold morning in November 2024, that memory is about to knock on your door with a warrant. Let me tell you about a woman named Ruth Martin. She was 23 years old in 1978. She was a nursing student in Cincinnati, Ohio. She lived in a small apartment near the hospital where she was doing her clinical rotations. She was engaged to be married. She was planning a wedding for the summer of 1979. On August 14, 1978, Ruth Martin didn't show up for her shift at the hospital. Her supervisor called her apartment. No answer. Her fiancé went to check on her. He found her in her bedroom. She'd been sexually assaulted and murdered. The crime scene was brutal, evidence of a prolonged attack, evidence of rage. Whoever had done this had spent time with her. This wasn't a quick act of violence. This was sustained. The Cincinnati Police Department processed the scene. This was 1978, 6 years before Alec Jeffries would invent DNA fingerprinting. The investigative tools available were fingerprints, blood typing, witness statements, and traditional detective work. They found fingerprints, but they didn't match anyone in the system. They found biological evidence, but all they could determine was blood type, type O, which describes nearly half of all humans. They canvassed the neighborhood, interviewed dozens of people, followed every lead they could generate. Nothing. The case went cold. Ruth Martin's fiancé spent the rest of his life wondering who had killed the woman he was supposed to marry. Ruth's parents died without ever knowing who had murdered their daughter. The evidence, blood samples, swabs, fingernail scrapings, was stored in the Cincinnati Police Department's evidence room. It sat there for decades, 46 years, through multiple police chiefs, through the transition from paper files to digital databases, through administrations and budget cuts and office moves. But someone kept it safe. Some evidence technician, whose name we'll probably never know, made sure that Ruth Martin's rape kit wasn't thrown away during a purge, wasn't misfiled, wasn't lost. And in 2022, that decision changed everything. In 2022, the Cincinnati Police Department received a grant. It was part of a nationwide initiative to process backlogged rape kits and cold case evidence using modern DNA technology. The department contracted with a private lab that specializes in forensic genealogy. The lab requested the Ruth Martin evidence. It arrived in a temperature-controlled container, carefully preserved. 44 years old. Some of the original investigators who collected it were dead. The detective who'd been the lead on the case had retired 20 years earlier and died in 2019. But the DNA was still viable. The lab extracted it using modern techniques that didn't exist in 1978. They amplified it. They sequenced it. They created a full STR profile from a man's biological material found at the scene. They ran it through CODIS. No match. So they did what's becoming standard practice now for cold cases. They uploaded the profile to GD-Match and Family Tree DNA, public genealogy databases where people upload their DNA to find relatives and trace their ancestry. They got hits. Distant relatives, third cousins, fourth cousins, people who had no idea they were about to help solve a 46-year-old murder. A forensic genealogist, let's call her Sarah because the actual genealogist's name is protected, began building a family tree. She started with the DNA matches and worked backwards, using public records to identify common ancestors. This is painstaking work. You're essentially constructing a multi-generational family diagram with hundreds, sometimes thousands of people. Birth records, marriage records, death certificates, census data, obituaries, immigration records, military service records. Sarah spent months on this. She built a tree with over 2,000 individuals in it. She traced family lines back to the 1800s. She identified every descendant of certain common ancestors, then narrowed down the pool by age, gender, and geographic location. She was looking for a man who would have been in his 20s or 30s in 1978, who would have been living in or near Cincinnati at the time, who was still alive. The pool narrowed.
50 candidates, then 20, then 5, then 1. Raymond D.J. Free. Raymond D.J. Free lived in a suburb of Cincinnati. He was 70 years old. He'd lived in the same house since the 1980s. He'd worked as a factory supervisor until his retirement. The genealogy data said he was a match. His age was right. His location was right. He had no alibi for August 14th, 1978. But then again, who would? That was 46 years ago. Most people can't remember where they were last month, let alone in the summer of 1978. But the investigators couldn't arrest him. Not yet. Not on genealogy alone. They needed his actual DNA to compare to the crime scene profile. So they did what they always do. They started surveillance. They followed Raymond D.J. Free to the grocery store, to the pharmacy, to his doctor's appointments. They watched him interact with his grandchildren. They watched him water his garden. They watched him take out his trash. They were waiting for him to discard something. And in September 2024, he did. He went to a fast food restaurant. He ordered a meal. He ate it in his car. And when he was done, he threw the trash, including a straw and a cup with his saliva on it, into the restaurant's outdoor trash receptacle. The surveillance team retrieved it. The lab extracted DNA from the straw. They ran it against the Ruth Martin crime scene profile. Perfect match. 46 years, 1 straw, justice waiting in a trash can. On November 7, 2024, at approximately 6 in the morning, the Cincinnati Police Department executed an arrest warrant at Raymond D.J. Free's residence. There's Bodycam footage of this arrest. You can find it online. It's been viewed millions of times, and it's one of the most surreal pieces of footage I've ever seen. The officers knock on the door. Raymond answers. He's in his bathrobe. He has white hair, glasses, the kind of gentle grandfatherly appearance that makes him look like he should be in a commercial for retirement planning. The lead detective identifies himself. He tells Raymond that he's under arrest for the murder of Ruth Martin, and Raymond says, "Who?" He doesn't remember her name. It's been 46 years. He's lived an entire life since that night. He got married, had children, celebrated birthdays and holidays and anniversaries, became a grandfather, retired, grew old, and somewhere along the way, he convinced himself that what happened in 1978 was buried, that it was gone, that he'd gotten away with it. The detective shows him a photograph of Ruth Martin, a young woman in a nursing uniform, smiling at the camera. Raymond looks at the photograph for a long time, and then he says, "I want a lawyer." He's currently awaiting trial. The prosecution has DNA evidence placing him at the scene. They have the genealogy tree showing the family connection. They have the straw from the fast food restaurant confirming his identity. Raymond D.J. Free is 70 years old. If convicted, he will die in prison. But Ruth Martin will finally have her name attached to justice. If you've ever wondered whether evil people ever truly sleep peacefully, whether they ever actually escape what they've done, whether 40 years is long enough to outrun your past, you now know the answer is no. Because here's what the Ruth Martin case proves. There is no statute of limitations on DNA. Evidence doesn't age out, molecules don't forget, and the technology is only getting better. Which brings us to the oldest case we're going to cover tonight. A case so old that the victim never even had a name. Until now. Case 4, Guy Muldavin. On July 26, 1974, a woman was walking on Race Point Beach in Provincetown, Massachusetts. It was early morning, the tide was out, the sand was still dark and wet. And there, partially buried in the dunes, was a body. A woman, nude, severely decomposed.
Her hands had been removed, her head had been nearly severed. The damage to the body suggested she'd been there for weeks, maybe longer. The elements, sun, salt, sand, had rendered her nearly unrecognizable. But someone had also deliberately mutilated her. Someone had tried to make sure she could never be identified. They removed her hands to eliminate fingerprints. They destroyed her dental structure to eliminate dental records. They left her in a remote location where she might never be found. And for 50 years, it worked. She became known as the Lady of the Dunes, one of America's most famous unidentified victims. Her death inspired books, documentaries, conspiracy theories. Some people claimed she was an extra in the movie Jaws, which was filming in Martha's Vineyard around that time. Others said she was connected to organized crime, to Whitey Bulger's network, to trafficking rings. But no one knew who she was. Her body was buried in an unmarked grave in Provincetown, a Jane Doe, a woman's whose entire existence had been reduced to a forensic description. Caucasian female, approximately 25 to 40 years old, 5'6", reddish-brown hair, gold dental work. And then, in 2023, 49 years after she was found, she got her name back. Here's the problem with identifying skeletal remains that are decades old. DNA degrades. It's a molecule, and like all molecules, it breaks down over time. Heat, moisture, UV radiation, bacterial action, all of these things destroy the chemical bonds that hold DNA together. In ideal conditions, cold, dry, dark, DNA can survive for thousands of years. In bad conditions, heat, humidity, exposure to the elements, it can be completely destroyed in a matter of months. The Lady of the Dunes had been buried in sand, exposed to salt air, subjected to temperature fluctuations, possibly damaged by animals and insects for weeks before she was found. Then her remains were stored in a morgue for years, then buried, then, in 2000, exhumed so investigators could try again to identify her. By the time modern DNA technology became available, her remains had been through hell. The first attempts to extract DNA failed. The samples were too degraded. What little genetic material remained was fragmented, broken into pieces so small they were unusable with traditional STR analysis. But in 2022, a new technology became available, Forensic Genetic Genealogy, using advanced sequencing techniques that can work with heavily degraded DNA. Instead of trying to analyze 13 specific loci like traditional STR analysis, this technique sequences hundreds of thousands of markers across the entire genome. It's called SNP analysis, single nucleotide polymorphism analysis. Even with fragmented, degraded DNA, if you can get enough small pieces, you can reconstruct a genetic profile. The FBI contracted with a private lab called Othram, which specializes in this kind of analysis. They sent the Lady of the Dunes remains, specifically a tooth, which tends to preserve DNA better than other tissues, to Othram's facility in Texas. And Othram performed something close to a miracle. Using SNP analysis, Othram extracted enough genetic information to create a genealogy profile. Not a full forensic profile, the DNA was too degraded for that, but enough data points to upload to genealogy databases and search for relatives. They found matches, distant cousins, people who'd uploaded their DNA to websites like Ancestry or 23andMe, never imagining they'd help identify a murder victim from 1974. A forensic genealogist built a family tree, traced lineages, cross-referenced records, narrowed down the possibilities, and in October 2022, the FBI announced the Lady of the Dunes' identity, Ruth Marie Terry. She was 37 years old when she died. She was from Tennessee originally. She'd moved to Massachusetts with her husband, Guy Muldavin, sometime in the 1970s. And Guy Muldavin was a very interesting person. Guy Muldavin had a pattern. He married women, and then those women disappeared. In 1960, his wife Manzanita Muldavin and her daughter from a previous marriage both vanished from their home in Seattle. Their bodies were buried in the basement. Guy was the prime suspect, but he fled before he could be arrested. The case went cold. In the 1970s, Guy remarried. His new wife was Ruth Marie Terry. They moved to Massachusetts, and in 1974, Ruth was found dead on a beach with her hands cut off. Guy Muldavin was never charged. There wasn't enough evidence. He had alibis, or claimed he did. He moved frequently, changed his name, reinvented himself. He eventually ended up in California, where he died in 2002. For decades, no one connected the Lady of the Dunes to Guy Muldavin. Ruth had been missing, but she was estranged from her family. There was no missing persons report that matched her description. The mutilation had made visual identification impossible, and without DNA technology, there was no way to connect skeletal remains to a specific identity. But the DNA survived. Fragments of it scattered through what was left of her tooth, microscopic pieces of evidence that waited 48 years to speak her name. Ruth Marie Terry died in 1974. She was buried as a Jane Doe. For nearly 50 years, she existed only as a mystery, a question mark, a piece of true crime folklore. But in 2023, she became a person again. She got her name back. Her family, what remained of it, got closure. Her grave marker was replaced with one that bears her actual name. And Guy Muldavin, who died in 2002, thinking he'd gotten away with it, was posthumously identified as the prime suspect in her murder. The dead can speak now. Their bones, their teeth, their hair, these are not just remains, they are witnesses, and they are patient. But Ruth Marie Terry's story raises a question that's going to haunt the next case. What about the victims who died as children, who never got to grow up, never got to have families of their own, never got to leave behind the kind of paper trail that makes genealogy possible? What about the children who were killed and discarded like garbage, who had no one to report them missing, no one to search for them, no one to even know they were gone? How do you give them their names back when they barely got a chance to have names in the first place? The answer involves the most complex genetic archaeology ever performed, and it starts with a cardboard box on the side of a road in Philadelphia.
Case 5. Joseph Augustus Zarelli, February 25, 1957. A college student is checking his muskrat traps in a wooded area of Philadelphia's Fox Chase neighborhood. It's cold, late winter. The trees are bare. He finds a cardboard box. It's a J.C. Penney bassinet box, the kind people use to store things. It's lying in the underbrush, partially covered by branches. He opens it. Inside is the body of a small boy, 4, maybe 5 years old. He's nude, wrapped in a plaid blanket. His hair has been cut, recently, poorly, as if someone was trying to change his appearance. His body shows signs of severe abuse, bruises, scars, malnourishment. The boy has been dead for probably a week or more. The Philadelphia Police Department responds. They process the scene. They take the boy's body to the morgue. They photograph him. They take his fingerprints. And then they begin the heartbreaking work of trying to figure out who he is. They distribute flyers with his photograph. They canvass the neighborhood. They check with local schools, hospitals, churches. They check missing children reports from across the entire East Coast. Nothing. No one recognizes him. No one has reported a boy his age missing. It's as if he never existed. They bury him in a potter's field. The gravestone reads, "Heavenly Father, bless this unknown boy." For 65 years, he was America's unknown child, until 2022. Here's what makes the boy in the box case one of the most challenging forensic identifications ever attempted. The boy died in 1957. His body was embalmed for viewing.
standard practice, but the embalming process introduces chemicals that destroy DNA. Then he was buried for 65 years in a wooden casket that eventually deteriorated, exposing his remains to soil, water, bacterial action, temperature fluctuations. When investigators exhumed his remains in 1919 to attempt DNA analysis, what they found was not much. Bones, some tissue, all of it severely degraded. The first DNA extraction attempts failed entirely. There simply wasn't enough viable genetic material. But the team working on the case, led by the same Othram lab that identified the Lady of the Dunes, didn't give up. They tried different bones, different extraction methods, different sequencing technologies. In 2021, they finally got a partial profile. Not enough for CODIS, not enough for a traditional forensic match, but enough for genetic genealogy. They uploaded it to GEDmatch, and this is where the case becomes a masterpiece of genealogical detective work. The DNA matches that came back were distant, fourth cousins, fifth cousins, people who shared ancestors with the boy from the 1800s. But there was enough data to work with. A team of forensic genealogists, led by a woman named Colleen Fitzpatrick, began building family trees, multiple trees for multiple ancestral lines. They were essentially reconstructing American genealogy from the 19th century forward, trying to find the intersection point where all these distant cousins' family trees converged. This took months, years actually. They built trees with thousands of people in them. They traced immigrant families who came to America from Ireland, from Italy, from Eastern Europe. They followed lineages through census records, birth certificates, marriage licenses, church records. They were looking for a family that would have had a boy the right age in 1957, a family in the Philadelphia area, a family that for some reason never reported that boy missing. And slowly, the tree began to narrow. They identified a couple, Joseph Augustus Zarelli and his wife. They'd lived in the Philadelphia area in the 1950s. They'd had children, but there was no record of what happened to those children. The family had dissolved, scattered. The wife had died years ago. Joseph had died in 1997. The genealogists kept digging. They found relatives of the Zarelli family who were still alive. They contacted them, asked if they remembered a child in the family that would have been about 4 or 5 in 1957. Some of them did, vaguely. There had been a boy, but they were very young themselves at the time. They didn't remember his name. They didn't know what happened to him. The family never talked about it. On December 8, 2022, 65 years after the boy was found, the Philadelphia Police Department held a press conference. They announced his name, Joseph Augustus Zarelli. He was 4 years old when he died. He'd been severely abused, possibly for his entire short life. The autopsy showed healed fractures, evidence of chronic malnourishment, signs of long-term neglect. And when he died, whether from abuse or illness or some combination of both, whoever was responsible for him didn't call a doctor, didn't call the police, didn't give him a funeral. They cut his hair to make him less recognizable. They wrapped him in a blanket, and they left him in the woods like garbage. For 65 years, no one came forward. No one admitted to knowing him. The people who could have identified him either stayed silent or died without speaking. But the DNA spoke. Fragments of it, pulled from bones that had been in the ground for more than half a century, molecules that survived embalming, burial, decay, time itself. Joseph Augustus Zarelli Jr. finally got his name back. His gravestone was replaced. It now reads his actual name. Strangers visit his grave now, leave flowers, leave toys. He's no longer the unknown boy. The investigation into who killed him is ongoing. Most of the likely suspects are dead, but even if no one is ever prosecuted, even if justice in the legal sense never comes, Joseph has something he didn't have for 65 years. His identity, his name, his place in history as a person, not a question mark. Joseph Zarelli's case shows us something remarkable. DNA can give voice to victims who never had a chance to speak for themselves. But there's a dark mirror to that truth. What if the person who hurt you is the same person who gave you half of your DNA? What if your father's crimes are solved because of your blood? What if your genetic inheritance includes not just your eye color and your height, but also your parents' guilt?
Case 6. Lonnie Franklin Jr. In 2008, a young man was arrested in Los Angeles for a felony weapons charge. Standard procedure. He was fingerprinted, photographed, and asked to provide a DNA sample. His DNA was entered into California's DNA database, and the system lit up like a Christmas tree. Not an exact match, a partial match, the kind of match you get when you're comparing DNA from close relatives. The database was telling investigators this person's DNA is very, very similar to DNA found at multiple crime scenes from the 1980s and 2000s. The young man's father was about to become one of the most notorious serial killers in Los Angeles history. His name was Lonnie Franklin Jr., and for over 2 decades, he'd been hunting women in South Los Angeles with such methodical patience that the police had nicknamed him the Grim Sleeper because of a 14-year gap between his known murders. But he only got caught because his son got arrested. This is where we need to talk about something deeply uncomfortable: familial DNA searching. When you give your DNA to law enforcement, either because you were arrested, or because you volunteered it, or because you uploaded it to a genealogy website, you are not just giving up your own genetic privacy. You are giving up your family's privacy, your parents, your children, your siblings, your cousins. Because here's how familial DNA searching works. When police have DNA from a crime scene and they run it through CODIS and get no exact matches, they can search for partial matches, people who share a significant percentage of their DNA with the unknown suspect. If you share 50% of your DNA with someone, you're either their parent, their child, or their sibling. If you share 25%, you're likely a grandparent, grandchild, aunt, uncle, niece, or nephew. If you share 12.5%, you're probably a first cousin. So when Lonnie Franklin Jr.'s son was arrested and his DNA was entered into the California database, the system detected that his DNA was a 50% match to DNA found at 10 different murder scenes from 1985 to 2007, which meant the killer is either this young man's father, his mother, or his sibling. Detectives pulled the family tree. Lonnie Franklin Jr. fit the profile. He was the right age, he lived in South Los Angeles, he'd been in the area during all the murders. But they couldn't arrest him, not on familial DNA alone. They needed his actual DNA. So they did what they always do. They followed him until he discarded something. July 7th, 2010. Lonnie Franklin Jr. goes to a pizza restaurant in Los Angeles. He orders food, he eats, he wipes his mouth with a napkin. He throws the napkin and his leftover crusts into the trash. He walks out. An undercover detective who has been sitting 3 tables away, pretending to read a newspaper, waits exactly 90 seconds. Then he walks to the trash can, reaches in, and retrieves the napkin and the pizza crusts. Lonnie Franklin Jr.'s saliva is all over them. The lab extracts DNA. They compare it to the crime scene samples. Perfect match, all 10 scenes. Lonnie Franklin Jr. is arrested at his home in South Los Angeles. He's convicted of 10 counts of murder, though investigators believe he may have killed as many as 25 women over a 25-year period.
and the evidence that convicted him includes DNA from 10 victims and genetic betrayal from his own son. When police searched Lonnie Franklin Jr.'s house after his arrest, they found something in his garage that still haunts every detective who saw it. Over 180 photographs, Polaroids mostly. Some are more recent digital prints. They show women. Many of them are unconscious or appear to be dead. Many are nude or partially clothed. Many show signs of violence. Not all of these women have been identified. Some of them may have survived. He may have photographed them while they were unconscious and let them go. Some of them may be among the Jane Does found in Los Angeles during the 1980s and 90s. The photographs are still being analyzed, still being compared to missing persons reports, still being shown to families who are searching for daughters, sisters, mothers who vanished decades ago. But here's what those photographs represent: evidence that Lonnie Franklin Jr. had been hunting for over 2 decades, evidence that he'd been documenting his crimes, evidence that he thought he was untouchable. And he was. For 25 years, he was a ghost. He worked as a garage attendant, a sanitation worker. He lived in the same house for decades. He had a girlfriend, a son, a normal-seeming life. But he was only caught because his son, who had nothing to do with his father's crimes, who was completely innocent, got arrested for an unrelated offense and had to give a DNA sample. Lonnie Franklin Jr. died in prison in 2020. He never confessed, never showed remorse, never identified all the women in the photographs. But his son has to live with the knowledge that his DNA is what ended his father's killing spree. His genetic inheritance included not just his physical traits, but his father's destruction. If you've ever thought about the invisible connections that tie us to people we didn't choose, our parents, our ancestors, our biological family, you're starting to understand why DNA is not just a tool for justice, it's a web. And once you're caught in it, there's no way out. Which brings us to someone who thought geography could save him.
Case 7, William Sapp. December 22, 1995. A woman in Tallahassee, Florida, comes home from her Christmas shopping. She's carrying bags of gifts. She's thinking about wrapping them later, about the dinner she's going to make, about the holiday party she's attending tomorrow. She unlocks her door. Someone is waiting inside. His name is William Sapp. He's crossed state lines from Ohio specifically to find her. He's been watching her, stalking her, and today he's decided that she's not going to survive the encounter. She does survive, barely, but another woman in Tallahassee around the same time doesn't. William Sapp commits both crimes within a 48-hour period. Then he gets in his car and drives back to Ohio. He thinks he's safe. He thinks that committing crimes in Florida and living in Ohio, he's created a gap that police can't cross, a jurisdictional black hole where evidence goes to die. For a while, he's right. Here's a dirty secret about American law enforcement in the 1990s. The states didn't talk to each other, not well anyway. If you committed a crime in Florida and you lived in Ohio, the Florida police would have your crime scene evidence, but they'd have no way to connect it to you unless you were arrested in Florida. And the Ohio police would have your criminal history, but they'd have no way to know about crimes you'd committed in other states unless you were arrested for them in Ohio. There was no national DNA database. Each state maintained its own database, but they didn't share information efficiently. CODIS, the Combined DNA Index System, existed, but it was in its infancy. Not all states participated. Not all states uploaded their data regularly. So, if you were smart, you committed your crimes in one state and lived in another. You exploited the gaps. William Sapp was smart. He committed crimes in Florida in 1995. He returned to Ohio. He laid low. He lived a normal life. He worked.
He paid taxes. He wasn't arrested for anything major. And because his DNA wasn't in Florida's database, and because Florida's unsolved cases weren't being cross-referenced with Ohio's criminal records, he became invisible for years. But in 1998, something changed. Congress passed the DNA Identification Act, which expanded CODIS and required states to upload their DNA profiles to the national database. It also required that convicted felons provide DNA samples. Slowly, over the late 1990s and early 2000s, the states began uploading their backlogged DNA evidence. Cold cases from the 80s and 90s were entered into the system. Convicted felons, even those convicted before DNA technology existed, were required to submit samples. In Ohio, William Sapp was convicted of a domestic assault charge in 1999. It was a relatively minor offense, but under the new DNA laws, he was required to provide a sample. His DNA was entered into Ohio's database, which was now connected to CODIS, which was now cross-referencing with Florida's database. And in 2003, 8 years after the crimes, William Sapp's DNA matched evidence from the 1995 Tallahassee murder and assault. Florida issued a warrant. Ohio arrested him. He was extradited. At trial, he was convicted almost entirely on DNA evidence. The surviving victim identified him. The DNA sealed it. He's currently serving life without parole. William Sapp's story is important because it marks the end of an era. The era when you could run, when you could cross state lines and disappear into a jurisdictional gap, when geography could save you from your own biology. That era is over. Today, all 50 states participate in CODIS. The database contains over 20 million profiles. It's cross-referenced internationally through Interpol. If your DNA is in the system anywhere, it's searchable everywhere. You can't hide by moving anymore. You can't hide by waiting anymore. You can't hide at all. But here's a question that's been haunting cold case investigators for the last few years. What happens when the killer is already dead? What happens when you solve a case and the person responsible is gone for decades? Does justice even matter if there's no one left to prosecute? The answer is yes, because justice isn't just about punishment. It's about names, identity, truth. And the next case proves that even death can't stop DNA from finding the truth. Case 8. Robert Bob Brashers. Between 1992 and 1993, someone was hunting people along Interstate 70. 6 robberies, 6 murders, all at small retail stores, bridal shops, specialty boutiques, ceramic stores, all in the Midwest, Indiana, Missouri, Texas, all committed in the middle of the day, during business hours. The killer would walk in, usually wearing a baseball cap pulled low. He'd shoot the clerks at close range, execution style, often while they were kneeling or lying on the floor. Then he'd take money from the register, never very much, a few $100s at most. Then he'd disappear. The FBI's Behavioral Analysis Unit profiled him. They said he was organized, intelligent, mobile, probably white male, 25 to 35 years old, probably had a legitimate reason to travel, a job as a salesman or truck driver. But despite a massive investigation, despite composite sketches, despite witness descriptions, despite ballistics analysis linking all 6 murders, the killer was never caught. The case went cold. Until 2020. In a police evidence room in Indianapolis, there was a box. It contained evidence from one of the I-70 murders, specifically the 1992 murder of a store clerk in Indianapolis. Inside that box, a cigarette butt, found near the crime scene,
possibly dropped by the killer. For nearly 30 years, that cigarette butt sat in the box. It had been processed for fingerprints in 1992, but no usable prints were found. DNA technology existed in 1992, but it was expensive, time-consuming, and required large samples. So the cigarette butt was logged and stored and forgotten. In 2019, Indianapolis Metro Police received funding to re-examine cold cases using modern DNA technology. They pulled the I-70 case files. They sent the cigarette butt to a lab. The lab extracted DNA. They created a profile. They run it through CODIS. No match. So they used Forensic Genealogy. They uploaded the profile to GED Match. They found distant relatives. They built a family tree. And in April 2020, they announced a suspect, Robert Bob Brashers. Robert Brashers died in 2002. He was shot and killed by police in Mississippi during an attempted burglary. He'd been in and out of prison for decades, small-time criminal, thief, drifter. He'd never been a major suspect in the I-70 murders. His name had come up during the original investigation. He fit the general profile. He'd been in the area during some of the murders, but there had been no physical evidence linking him to the scenes, until they matched his DNA to the cigarette butt. And once they knew who he was, they could go back through the records, check his movements, cross-reference his known locations with the murder timeline. Perfect match. Every murder occurred in a city where Robert Brashers had been living or passing through at the time. He was the I-70 killer, and he'd been dead for 18 years by the time they figured it out. So what does justice look like when the perpetrator is already gone? It looks like this. The families of the 6 victims who spent nearly 30 years wondering why their loved ones died, wondering if the killer was still out there, wondering if he'd ever be caught, finally got answers. They got a name. They got confirmation that the person who destroyed their families wasn't living freely somewhere. They got closure. Not the closure of a trial, not the closure of watching someone led away in handcuffs, but the closure of knowing. And for some families, that's enough. For others, it's not. Because Robert Brashers will never be held accountable. He'll never be questioned. He'll never be forced to explain why he walked into those stores and executed those people for a few $100s. But his DNA spoke for him. Even in death, his body testified against him. Robert Brashers' case shows us that DNA doesn't care about the passage of time. It doesn't care if you're alive or dead. It will identify you eventually. But what happens when DNA has to identify not one killer, not one victim, but an entire burial ground of victims? What happens when you find 11 bodies in the desert and you have to figure out not just who they were, but who put them there? The answer involves some of the most cutting-edge forensic technology ever developed, and it's happening right now.
Case 9, February 2, 2009. A woman is walking her dog in an undeveloped area on the West Mesa of Albuquerque, New Mexico. It's dry, dusty, dotted with scrub brush, the kind of place where developers plan subdivisions but haven't broken ground yet. Her dog starts digging and unearths a human bone. The woman calls the police. They respond. They bring cadaver dogs. They start a systematic search of the area. By the time they're done, they've found the remains of 11 women and 1 unborn child, all buried in shallow graves, all between the ages of 15 and 32, all with histories of drug addiction and survival sex work, all missing between 2003 and 2005. Someone had been hunting vulnerable women in Albuquerque. Someone had been burying them in the desert.
Someone had turned a vacant lot on the edge of the city into a mass grave. And for 15 years, despite one of the largest investigations in New Mexico history, that someone remained unknown until 2024. Here's the challenge with the West Mesa case. The bodies had been in the desert for years, some for over a decade. The New Mexico climate, extreme heat, extreme cold, intense UV exposure, is about as hostile to DNA preservation as you can get. By the time the bodies were discovered, they'd been reduced to skeletons, in some cases partial skeletons. Scavengers had scattered remains, weather had degraded them, time had broken them down. The initial DNA extractions done in 2009 and 2010 were partially successful. Investigators were able to identify most of the victims using a combination of DNA, dental records, and personal effects found with the remains. 11 women got their names back. But identifying the killer was different. In most cases, if there's no semen or blood from the perpetrator at the scene, the only DNA you might find is trace DNA, skin cells, hair, saliva. And in a desert environment, exposed to the elements for years, that kind of DNA degrades into nothing. So for years, investigators had a burial ground, they had victims' identities, but they had no DNA evidence linking anyone to the murders. Dead end. Except, in 2022, a new forensic technique became available: soil DNA analysis. Here's how it works. When a body decomposes, it releases DNA to the surrounding soil. Cellular material breaks down and leaches into the earth. In most cases, this DNA degrades rapidly. Bacterial action, moisture, soil chemistry all destroy it. But in very specific conditions, dry soil, high alkalinity, low organic activity, perfect conditions. In 2023, the Albuquerque Police Department, working with the FBI and private forensic labs, took new soil samples from the burial sites. Specifically, they took soil that would have been in direct contact with the bodies during decomposition. They used advanced sequencing techniques to extract any human DNA that didn't belong to the victims. And they found something. Male DNA, fragmented, degraded, but present in multiple graves. The same male DNA in several different burial sites, which meant the person who buried these women left his genetic signature in the soil itself. The DNA profile was uploaded to genealogy databases, family trees were built, suspects were identified, and as of late 2024, law enforcement sources have confirmed, though they won't officially announce it yet, that they've narrowed their suspect pool to fewer than 5 individuals. Some of those individuals are dead, some of them are alive. The investigation is ongoing. They're building the evidence, they're testing the DNA against the suspects, they're constructing a case that can withstand trial. But the breakthrough has happened. After 15 years, the West Mesa bone collector is no longer completely unknown. His DNA is in the soil, his family tree is mapped, his identity is close to being revealed. And when that announcement comes, when law enforcement finally holds the press conference and says, "We know who he is," it will be because of technology that didn't exist when those women were buried. Technology that can pull DNA out of dirt. Technology that can reconstruct genetic profiles from fragments so small they're measured in picograms. Technology that turns the earth itself into a witness. We've seen DNA extracted from 7 microscopic cells on a knife sheath, from a single hair on burlap, from a straw in a fast food trash can, from the bones of a child buried 65 years, from soil in a desert grave. But there's one more case we need to cover. The newest case, the fastest case, the case that shows you where this technology is going and why no one can ever hide anymore. Because DNA isn't just biological now, it's digital.
Case 10, Tanner Horner, December 2nd, 2022. A 7-year-old girl named Athena Strand is waiting for a package delivery at her home in Paradise, Texas. It's a small town, rural, the kind of place where everyone knows everyone. A FedEx truck pulls up. The driver is a man named Tanner Horner. He's 31 years old. He's worked for FedEx for less than a year. He delivers the package, and then he abducts Athena. By the time her family realizes she's missing, by the time they call 911, by the time the police respond, she's already dead. But Tanner Horner doesn't know this yet. He's already been caught. Not by a witness, not by a camera, not by traditional forensic evidence, by his truck. Modern delivery vehicles are surveillance systems on wheels. Every FedEx truck, every UPS van, every Amazon delivery vehicle is equipped with GPS tracking that logs its location every few seconds. The system records where the truck is at any given moment, how long it stays at each location, what route it takes between stops, how fast it's driving, when it stops and starts. The data is uploaded to company servers in real time. It's used for route optimization, for customer service, for efficiency metrics, but it's also a perfect forensic timeline. When Athena Strand was reported missing, the Wise County Sheriff's Office immediately contacted FedEx. They requested GPS data for every delivery truck in the area that afternoon. Tanner Horner's truck showed something unusual. It had stopped at the Strand residence for 7 minutes. The average delivery stop is less than 2 minutes. And after leaving the Strand residence, the truck had deviated from its assigned route. It had driven to a rural area about 10 miles away. It had stopped there for 22 minutes. Then it had returned to its route. The police had a timeline. They had a location. They sent officers to the area where the truck had stopped. They found Athena's body. But the GPS data was just the beginning. Modern delivery drivers also use handheld scanners, essentially specialized smartphones. These scanners have their own GPS. They log every package scan. They take photos of deliveries. They record the exact time each package is delivered. Tanner Horner's scanner data showed he scanned a package at the Strand residence at 4:38 p.m. He took a delivery photo at 4:39 p.m. The scanner's GPS showed movement away from the residence at 4:45 p.m. 6 minutes. He'd been there for 6 minutes after completing the delivery. The truck's GPS and the scanner's GPS matched perfectly. There was no gap, no ambiguity. The data placed him at the location where Athena was taken, at the exact time she was taken. And then there was the FedEx truck's internal camera system. Yes, modern delivery trucks have cameras inside the cab. They're pointed at the driver, ostensibly for safety and training purposes. They record continuously during shifts. The police obtained the footage from Tanner Horner's truck. It showed him driving, alone at first. Then, after the Strand residence stop, there was movement in the back of the cab, just out of frame, but visible. Someone was in the truck who hadn't been there before. Tanner Horner was arrested on December 2nd, 2022, the same day Athena disappeared, less than 12 hours after the abduction. There's Bodycam footage of his arrest. You can watch it online. It's been viewed millions of times. The police don't tell him why he's being arrested at first. They take him to the station. They put him in an interrogation room. And then they lay out the evidence. Your truck's GPS puts you at the Strand residence for 7 minutes. Your scanner data shows you completed the delivery in 1 minute. That's 6 minutes unaccounted for.
Your truck then drove to location where we found Athena's body. Your truck's camera shows someone was in the vehicle after you left the Strand residence. We have your complete route. We have your complete timeline. We have video of the inside of your truck. Tanner Horner sits there. He doesn't have a lawyer yet. He should ask for one. He doesn't. And then he confesses. He admits to abducting Athena. He admits to killing her because she saw his face and he panicked. He admits to hiding her body. The entire interrogation, from her arrest to her confession, takes less than 4 hours. From abduction to confession, 12 hours. Tanner Horner is currently serving life in prison without the possibility of parole. He was convicted in 2023. The trial took less than a week. The jury deliberated less than an hour. The evidence was overwhelming, undeniable, inescapable, because his truck testified against him. Not his biological DNA, though they found that too, of course. They found Athena's DNA in his truck. They found his DNA on her clothing. But they didn't need it for the arrest. They didn't need it to place him at the scene. They had something better. Digital DNA. A perfect record of his movements, a perfect timeline of his actions, a perfect cage built from GPS coordinates and timestamps and camera footage. He couldn't lie about where he was. He couldn't claim mistaken identity. He couldn't say the evidence was contaminated or mishandled. The data simply existed. Objective, irrefutable. Merciless.
So let's come back to where we started. What if the one thing that makes you unique is the same thing that will eventually destroy you? We've seen this truth play out 10 different ways. Bryan Kohberger's 7 skin cells, Rex Heuermann's single hair, Raymond DJ Free's fast food straw after 40 years, Ruth Marie Terry's DNA in a 50-year-old tooth, Joseph Zarelli's DNA from embalmed bones, Lonnie Franklin Jr. caught by his son's arrest, William Sapp caught by interstate data sharing, Robert Brashers identified after death, the West Mesa bone collector identified through soil, Tanner Horner caught by his truck in 12 hours, 10 predators, 10 different decades, 10 different methods, but one unifying truth. Your body is a witness you can never silence. Think about what this means for you. Not as a criminal, because most of you watching this aren't planning to commit crimes, but as a person living in the modern world. Right now, as you watch this, you are creating a genetic trail. You're shedding skin cells onto your keyboard, your phone screen, your couch. You're leaving saliva on your coffee cups, your water bottles, your silverware. You're leaving hair in your car, in your bathroom, on your pillow. Every surface you touch becomes a potential crime scene. Every object you discard becomes potential evidence. If someone wanted to build a case against you for anything, they could probably collect your DNA without you even knowing. They could follow you to a restaurant and take your fork. They could retrieve your discarded Starbucks cup. They could collect hair from your barber. And once they have your DNA, they have your genetic identity, the biological barcode that is unique to you and you alone. This isn't science fiction. This is the world you live in now. But here's the other side of that coin. DNA technology is solving cases that were unsolvable for decades. It's giving names back to Jane and John Does who died anonymous. It's giving closure to families who spent years in limbo. It's catching predators who thought they were ghosts. The boy in the box finally got his name, Joseph Augustus Zarelli. The Lady of the Dunes finally got her name, Ruth Marie Terry.
4 university students in Idaho got justice through 7 microscopic cells. Athena Strand's family got answers within 12 hours because a truck was watching. This technology is rewriting what justice looks like. It's collapsing the distance between crime and consequence. It's making the statute of limitations on DNA essentially infinite. Evidence that's 40 years old is now viable. Evidence that's 50 years old can still speak. Evidence that's been buried, degraded, contaminated, and forgotten can still identify the guilty. So here's the answer to our master mystery. DNA doesn't just make you unique, it makes you permanent. You cannot erase it, you cannot destroy it completely, you cannot outrun it. And for people who committed crimes in the 1970s, the 1980s, the 1990s, the 2000s, people who thought they'd gotten away with it, who thought time was on their side, who thought their secrets were buried, this is terrifying, because the evidence is still there, sitting in evidence rooms, stored in freezers, cataloged in boxes, waiting for the technology to catch up, waiting for the databases to expand, waiting for someone to upload their family tree to a genealogy website, waiting. And when the time comes, that evidence will speak. It will name names. It will point fingers. It will drag people out of their comfortable retirements and their normal lives and their decades-long silences. There are thousands of cold cases still unsolved in America. Thousands of victims who never got justice. Thousands of families who never got answers. But every month, that number shrinks. Every month, another case is solved using forensic genealogy. Every month, another predator is identified, arrested, prosecuted. Every month, DNA speaks a little louder. And the people who thought they were safe, the ones who thought 40 years was long enough, the ones who thought they could hide in geography or silence or death itself, they're learning what Ruth Marie Terry's killer learned, what Joseph Zarelli's killer learned, what Raymond D.J. Free learned, what every person we've covered tonight learned. There is no statute of limitations on molecules. There is no safe distance from your own biology, and there is no escape from the one witness that never forgets.
If you started watching this because you wanted to understand how killers get caught, you now know they get caught by themselves, by their own cells, by their own genetic code. If you started watching this because you care about justice for victims, you now know justice is patient. It can wait 40 years, 50 years, 65 years. It will wait as long as it takes for the technology to exist that can make the evidence speak. If you started watching this because you were fascinated by the science, you now know we've moved beyond fingerprints and blood types. We're reading genetic code from soil, from bones buried for decades, from single hairs on burlap sacks. We're using family trees built from strangers' DNA. We're using GPS data as digital DNA. And if you started watching this because you've ever felt like terrible people get away with terrible things, you now know that's becoming less true every single day. Because DNA doesn't care how smart you are. It doesn't care how much time has passed. It doesn't care if you're alive or dead. It only cares about the truth, and eventually, it will tell it. Right now, somewhere in America, there's an evidence box sitting on a shelf. Inside that box is a swab, a hair, a piece of fabric, a cigarette butt, some microscopic fragment of human biological material that was collected 20, 30, 40 years ago. The person who left that evidence might be dead. They might be old, living quietly, convinced they got away with it. They might not even remember the crime anymore. But that evidence remembers, and it's waiting. Waiting for the technology to catch up.
waiting for someone to search the right database, waiting for a distant cousin to upload their ancestry results, waiting for a familial match, waiting to speak. And when it does, justice won't feel like it came late. It'll feel like it came exactly when it was supposed to.